Hi, my name is Kylie McIntosh, and I'm going to be talking about database virtualization. So virtualization is basically characterized by the shift from managing dedicated physical servers to managing logical resources. It's a concept that's been around since the 1960s, and now almost everything in a data center environment can be virtualized, including databases. So the concept of database virtualization is difficult to attach a single meaning to because it has different associated meanings. One possible definition is a database run on a virtual machine, which results in the ability to pull and repurpose compute and storage resources as needed. Another possible definition is virtualization and sharding. This technique partitions the database into multiple identical images that store unique data. Storage virtualization might also be considered database virtualization and simply involves the separation of logical storage from physical storage so that data can be accessed without reference to a physical location. Another possible definition is database virtualization and replication, which basically just allows database instances to be linked and imitated through replication. Another possible meaning is sharded databases with SQL routing, in which a SQL-aware load balancing process is run over sharded databases to make routing database requests to the appropriate server easier. Lastly, the concept that is probably the closest to full database virtualization is that of shared data cluster databases. Shared data databases basically separate both the compute and the storage into virtual blocks, which allows each function to be virtualized and scaled independently. So again, shared data cluster databases are probably the closest idea to a fully virtualized database. Mike Hogan, who is the CEO of Skill Database, also asserts that to be a truly virtualized database, a database must have the following features. First, she says it should allow the database application to talk to a single virtual instance of a database, even if there are multiple nodes acting over the data. Second, it should separate the data processing or compute from the data so that each can scale independently. Additionally, it should enable the processing of the data to be distributed to the various storage nodes to maximize performance. And lastly, it should have tiered caching to ensure cache coherency throughout the database cluster. To put its usefulness into perspective, Hogan also provides a problem scenario which could be solved by true database virtualization, and not simply a database run in a virtual machine. For example, a database that handles banking has to wire out $10 million. However, the bank is busy, so it bursts the database across 3 virtual machine nodes, which will each wire out $10 million, resulting in a total transfer of $30 million. To resolve this issue, all of the nodes should be able to see the same data and be able to prevent other nodes from altering the data independently. Full database virtualization should be able to provide this kind of mechanism. To elaborate more on the benefits of database virtualization, it provides faster cross-database functions, since each database node can view the entire database and process functions independently. Another performance advantage is the parallelization of queries. This allows queries to be distributed to various storage nodes, which will each process a portion of the data, and the database node will collect the results from the storage nodes and return these results. In more general terms, there are 10 basic advantages to shared data cluster databases that other forms of database virtualization do not always have. These advantages are the pooling of unused resources, the ability to dynamically add more compute power and storage from additional servers, the ability to dynamically add and remove compute power and storage from pooled servers, the high availability of both compute and storage, and also the ability to address any node regardless of the query, the ability to move a compute node to another server without shutting down the database, the ability to move database files to another storage node without shutting down the database as well. Now I'm going to talk about some of the constraints of database virtualization. Like the definition of the concept, these are kind of difficult to pinpoint because there are multiple interpretations of what database virtualization is. If database virtualization simply refers to virtualization of the server, it might not be appropriate for all database workloads. Heavier database workloads will have greater associated performance costs, so it might be better to only virtualize lesser used databases in an environment. Additionally, the technique that involves database virtualization replication has its own constraints. First, it requires specialized storage systems that can take snapshots of the file system. Additionally, the management of these kinds of virtual databases requires complicated scripting. However, both of these issues have been mitigated by the availability of automated solutions on the market. So, from the standpoint of a database administrator, the impacts of virtualizing the databases they manage are not necessarily bad and are generally positive, but obviously involve some changes. Virtualization software will arrive with its own integrated means of tuning the virtualized databases, but this allows a database administrator to tune whole sets of databases at a time. Another beneficial impact of database virtualization is how the fragmentation of the database facilitates keeping different parts of the database in different locations. Additionally, because the various database parts are replicas, they can be individually taken offline for repair, and the performance of the database as a whole will not be impacted. The benefit of replicated sections also applies if the data is somehow lost in one or more sections. The database administrator also does not have to worry about the backup and replication processes in the database, since these are often automated by the virtualization software. So now I'm going to talk about a real example of a corporation that decided to virtualize their databases. They decided to do this after learning that the hardware for its testing environment, which basically had copies of the production database, would expire, and they would have been really expensive to replace. So they decided to use Delphix. Delphix is virtualization software, which takes snapshots of production databases and runs them in a virtual environment. And these snapshots have the functionality of the production database, but they have reduced data redundancy. And these are more cost effective than if Pella Corporation had to completely replace their storage area networks that they were using for their testing environment.